Yes. So today's topic is rules for determining significant figures. Rules for determining significant figures. As I told you, please write each and everything. Without writing, you'll not be able to understand anything later on. Now, what we are going to do in this topic is, in case we are given a number, then how many are significant figures, significant digits in that given number? That's what we are going to decide in this topic. Right? There are some rules for that. Rule number one, all non-digit, all non-zero digits, all non-zero digits are significant. All non-zero digits are significant figures. For significant figures, you can write SF, right? Just to save time. For example, has 4 significant figures. All non-zero digits in this case are significant figures. Rule number 2. All zeros which come in between, non-zero digits are significant figures. For example, these 2 zeros are also significant figures. It means this has total 5 significant figures. Rule number 3. All zeros on the right hand side of non-zero digit, but on the left hand side of decimal point are significant figures. For example, see, according to the rule, zeros which come after non-zero digits, but they are on the left hand side of decimal place, they are significant figures. So this is not significant. These are significant figures as 4 significant figures. Next rule, number 4. In non-decimal numbers, look here, non-decimal means if I remove this 0, this is a non-decimal number. So write down, in non-decimal numbers, terminal zeros on the right hand side of non-zero digits are not significant figures. For example, now look here, this will be an interesting rule. I told you this has 4 significant figures, but if I remove this, there's no decimal point. These are non-zero digits. On the right hand side, these 2 zeros, they are not significant. So write down, for example, this has 2 significant figures. Further write down, same rule, part of the same rule. But these zeros are significant if they come from a measurement. If they come from a measurement. For example, see, just now I said 5,300. It has two significant figures. But if I say 5,300 grams or 5,300 meters, then these two zeros are also significant figures. So they have four significant figures because gram or meter or kilograms, they're all measurements. So in those cases, zeros which come after non-zero digits, but they are before decimal place. They are, non-decimal figures, they are significant figures. These two zeros will also be significant. Next rule. Now, next rule is for those quantities which, those values which are less than 1. It means 0 point something, right? Right on. Next rule, for less than 1 values, zeros between decimal and first non-zero digit are not significant. For example, first of all, this value should be less than 1, right? Zeros which come after decimal, they are not significant, and these are the zeros which are coming before non-zero digit. So no significance. This has two significant figures, right? Next rule. Zeros at the end of decimal figure are significant. For example, write on this one, 2.500. These two zeros which come at the end of decimal place, they are significant figures. Has four significant figures. Now, can you tell me how many significant figures are present in the second example?
Two significant figures.
Yes, these are two significant figures. Which zero is non-significant? First or the last?
The first one.
First one is non-significant. No significance, yes, and yes has two significant figures. Next rule. First, look at the board. You know the value of Avogadro's number. Avogadro's number is 6.022 into 10 to the power 23. This value is called exponential value. And this value is called first term, TERM. And this is called scientific notation. And in the scientific notation, first term has significant figures and exponential term is not considered. So write down the rule. In scientific notations, only the first term figures have significant figures. Full stop. Exponent term is not considered. Exponent term is not significant. For example, like this one has 4 significant figures. Those which are significant, for them I'll mark a tick, right? Those which are not significant, I'll mark a cross. So these are 4 significant figures. This is not significant, 4 significant figures.
Sir, but now, in the example you gave, won't over here 0 not be considered?
So this will be considered, because although this is coming after 0, but this is more than one value.
Okay, sir. Okay.
Right. Now I'll give interesting example. Same rule, write down next example. These zeros which come before decimal, they are significant. This 0 which comes after decimal is not significant. Has 1, 2, 3, 4, 5 significant figures. Now the same value I can write in the form of scientific notation. This I can write as 5 into 10 to the power 5. It's the same value. But according to the rule which I told you, this has only this significant figure. This is not significant figure. I can also write it 50 into 10 to the power 4. This has 2 significant figures. This and this, not this.
Sir, in the 50, why is 0 considered as significant?
Oh, yes. Now, if we write only 50, then 1 significant figure. If we write 50.0, then 2 significant figures. Next rule. Now let us say we add or subtract some quantities. Then generally you might have experienced, we generally round off the value which we obtain after addition or subtraction. Now, how should we represent our answer? For that, write down the rule. Write down, when numbers are added or subtracted, when numbers are added or subtracted, answer should be rounded off to the same number of decimal places as present in the number with least number of decimal places which is being added or subtracted. Example will make it clear what I wanted to say here. For example, 154.2 plus 6.1 plus 23. If I add, it comes to 183.3. Now, when I report this answer, should the answer be 183.3 or the answer should be 183? In case I have to round off, then what is the rule which I should apply? Look here. Out of these values which I'm adding, which value has no figure after decimal? This is Tell me.
23.
23. So the number which has least number of digits after the decimal is 23, and 23 has no digit after decimal. It means in my answer also, there should not be any digit after decimal. It means is reported as 183. So when I report the answer according to the rule, it should not be 183.3, it should be 183. I'll take one more sum. I hope you have noted down. One more value. 4.523 plus 2.3 plus 6.24. This comes out to 13.063. Now, which of these has least number of digits after decimal?
2.3.
This one. One digit after decimal. It means in my answer also there should be one digit after decimal. It means this. But after this first digit, that is 0, this is the digit, will say this is the digit which is to be retained. I'll repeat, 0 will be called the digit which is to be retained. After this digit 0, we have to see the next number, then only we'll decide how do we round off. Should I take it 13.0 or we should take it 13.1? Obviously, we should take it 13.1, but there are rules for that. How do we round off? Round off. Write down. This result is reported. This result is reported to one decimal place. Reported to one decimal place for which value has to be rounded off. Value has to be rounded off. This rounded off value is 13.1, which is decided on the basis of following rules. Decided on the basis of following rules. Now write down rules. I'll write it was 13.063. Rule number A. Rule number A. If the digit next to the digit to be retained, I'm talking about this one. I'll repeat, if the digit next to the digit to be retained is more than 5, like this one is more than 5, then the digit to be retained is increased by 1, and all other digits on the right hand side are dropped. Thus, in the above answer, means this one, in the above answer, 0 becomes 1 and 6, 3 are dropped. That is, answer is 13.1. I'm sure you might have the feeling nothing new. You already knew about it. I understand. But let us see what happens in the next rule. Right on B part means second rule of rounding off. Pattern. If the digit next to the digit to be retained is less than 5, then the digit to be retained will be used as such, and all other digits on the right hand side will be dropped. For example, rule will make it clear. For example, 12.652 plus 5.72 plus 22.2511. It comes out to 40.6231. First of all, tell me, to how many decimal places should I report my answer?
2 decimal places.
2 decimal places, because this has 2 digits after decimal. This has 3, this has 4, this has least, that is 2. It means I should report my answer up to 2 decimal places. It means 6 and 2 should be retained. So digits to be retained are 6 and 2. Now, after 2, the next figure is less than 5. I'll repeat. After 2, these are 2 digits to be retained. After 2, the next digit is less than 5. That is why 2 remains 2. It will not be increased to 3. Right on. This answer, according to the rule, should be reported as 40.62 and 3.1 should be dropped because 3 is less than 5. 3 is less than 5. Even this, to some extent, I'm sure is new for you, because to how many digits should we report our answer, that was something which is new for you. But the problem comes if it is above 5, if it is below 5, it is okay. But if it is 5, then what do we do? Right on C, third rule. If the digit next to the digit to be retained is 5, then the digit to be retained is not changed if it is an even number. Underline this, if it is an even number. But if it is an odd number, it is increased by 1. It is increased by 1. So this is interesting.
So could you repeat that, please? I didn't get you.
How much have you written? Even part you have written? Even? Hello? Have you written the even statement?
I've written, sir, if the digit next to the digit to be retained is 5, then the number to be rounded off. After that, I lost you, sir. Sorry.
Okay. Then the digit to be retained is not changed if it is an even number, but if it is an odd number, it is increased by 1. It is increased by 1. For example, 12.448 plus 3.5274 minus 5.11. This comes out to 10.8654. First of all, let us see to how many decimal places should I report my answer.
2 decimal places.
2.
2 decimal places. 2 digits after decimal. It means I should report my answer to up to 2 decimal places. I've underlined 8 and 6. Now, after 6 is 5. What should I do? Should I increase by 1 or should I not increase? Rule says if the digit which comes before 5, first of all, keep in mind we have to retain 8 and 6. Digit next to the digit to be retained. Digit next to the digit to be retained is 5. Now, if this 5 is followed by even number, then 8, 6 will be used as such. There will be no change. So first write down about it. This answer should be reported to 2 decimal places. 2 decimal places because 5.11 has minimum number of digits after decimal, but after rounding off, reported answer will be 10.86, while 5.4 will be dropped. 5.4 will be dropped. So this was the case when this is even number. Now I'll take another example in which it is an odd number. 12.538, 3.5274 minus 5.11. This is 10.9554. Right on. This answer should be reported up to tell me how many decimal places?
2.
Up to 2 decimal places. Reason is this, 2 decimal places, but it is rounded off to. Now tell me, how do I round off? It becomes
96.
96 because this is the last digit to be retained. After this is 5, and since this digit to be retained is an odd number, this will be increased by 5. So reported answer is 10.96. 10.96. So these were rounding off rules for addition and subtraction. Next rule will be when we are multiplying or dividing some numbers, then how should we report our answer? Write down. Result of multiplication or division. Multiplication or division of numbers should be reported to the same number of significant figures. Remember, significant figures, not figures after decimal, should be reported to same number of significant figures as present in the number with least number of significant figures. In such cases, exact numbers are not considered. If there's confusion, let me modify. In such cases, exact numbers multiplied or divided are not considered. Now, example, look here. Let us say 4.327 multiplied by 2.8. This comes out to 12.1156. Which of the two figures which are multiplied has minimum number of significant figures, not
2.8.
digits after decimal? Significant figures, how many?
2.8.
How many significant figures?
2.
Yes. It means I should report my answer up to 2 significant figures. And what will be 2 significant figures in this case? These 2. Now, after this, if I think of rounding off, naturally, this is less than 5. So there's no point rounding off to the next figure. It will remain as such. My answer will be 12. Right on. This result should be reported up to 2 significant figures, because 2.8 has minimum number of SF. Minimum number of SF. Thus, the reported answer should be 12. Now we'll consider when we divide. Another example. 0.46 divided by 15.734. This comes out to 0.029236. Out of 2 quantities which I have used in division, which one has the least number of significant figures?
0.46.
0.46.
Right? It means I should report my answer to 2 significant figures. In this answer, which 2 are significant figures?
2 and 9 would be significant.
Yes. 0, this is the value less than 1. And I told you earlier, 0 which comes after decimal. This is only on in those cases when the value is less than 1. So 0 which comes after decimal point, that is not significant. It means two significant figures will be these two, not this. After 9 is 2. If you think of rounding of rules, 9 will remain 9. It will not change. Got it? Write down. This result should be reported with two significant figures because 0.46 has 2 SF. Thus, the reported answer is 0.029. Right? Not significant, significant, and significant. Now we are coming to the last rule. In the last rule, we'll consider that if there are more than two quantities involved in multiplication or division, if there is a complicated calculation, then how do we report our answer? Write down. In a calculation involving a number of steps. Number of steps means many quantities are being multiplied or divided. Number of steps, then the result should be reported. Then the result should be reported to the same number of significant figures as present in the number with the least number of significant figures other than exact numbers. Exact number means 24, 46. These are exact numbers. So they will not be considered. For example, let us say it is 42.9670 multiplied by 0.02435 divided by 0.340 multiplied by 4. This comes out to 0.7692988. First of all, to how many significant figures should I report my answer? To how many significant figures should I report my answer?
Will it be 1? Because 4 is
Yeah.
No.
4.
See, that's what I said at the end of what I dictated. Exact numbers are not considered.
So then it will be 2 then.
2.
4 is an exact number, will not be considered. So how many significant figure, what is the least number of significant figures except this one?
So 3 होगा ना 0.340.
This is the one, because in this case, even the 0 which is coming at the end, that is significant. Had it been 340, then 3 and 4 were significant, 0 was not significant. Now, 3 significant figures. It means I should report my answer up to these 3 digits. After 9 is 2, so answer will remain this. But remember one thing, if it was 5, then tell me, had this been 5, then what would have been the answer?
0.7.
Yes,
17.
7. Had this been 8,
Become
Yes.
6. It'll become 9 because it'll
No.
remain the same. It'll remain the same.
no, you have forgotten. I told you, if this is even number and next digit is 5, even number will not be changed. Odd number will be increased by 1 if it is followed by 5. Right? So anyways, this was 9, 2. Now write down this answer or this result should be reported with 3 SFs, 3 significant figures, because 0.340 has 3 significant figures. Thus, the reported answer is 0.769. 0.769. So we have finished the rules, but in this very example, I'll ask you one thing. In place of 0.340, if I write 0.34, then I should report my answer up to
Two
Two
significant.
digits, right? 2 significant figures. And 2 significant figures are these two. This 6 is followed by a number more than 5. It means this will become 7. So answer would have been 0.77.
Yeah.
Right? Sure. So this topic we finished just now. Although very rarely question is asked in your school exam, but sometimes question comes in competitive exam. But it has been very much a part of your syllabus. It has always been a part of your CBSE syllabus. Next topic. Now we again come to very simple topics. Atom.
So, which chapter does this topic belong to? The one you just taught us?
This is the first chapter, some basic concepts of chemistry.
Okay, thank you, sir.
Next topic. Now we take up about atoms and molecules. Next, write on atom. Before I start dictating, tell me, an atom is a part of element or compound or mixture?
An element.
And what about molecule?
It's a
compound.
group of atoms.
Repeat. Repeat your answer.
It's
Molecule,
part of a compound.
part of compound.
So
Any
molecule
answer?
is a group of atoms.
Yes, it's a group of atoms. No doubt, it's a group of atoms. But can we have molecule of an element, compound, and mixture, all the 3, or 2 of them, or 1 of them?
So, a molecule is a part of a compound and a mixture.
It's even part of an element, right?
Yeah.
Right. Now, I'll tell you now. There's no question of mixture here. Molecule like O2 is the molecule of element. Molecule like water is the molecule of compound. Right? So molecules may be of elements and compounds, but atoms are of elements only, not of compounds. Right? Right on, atom. It is the smallest particle of an element which may or may not be capable of independent existence. If I say may or may not be capable of independent existence, what does it mean? If I say capable of independent existence, it means it is stable. If I say not capable of independent existence, it means it is not stable. You know, all noble gases are stable. their atoms can exist independently. They need not combine with any other atom. But if we talk about atoms of most of the elements, they are unstable. They need to combine with atoms of other elements or same element, right? For example, helium, neon, argon, these are stable atoms. H, N, O, etc. These three are stable. These three are not stable atoms because they cannot exist independently. They have to combine with some other atoms. Next definition, molecule. As I told you, will take up all basics, everything. Molecule. It is that smallest particle of an element or a compound which is made up of two or more atoms and is capable of independent existence. It means molecule is stable. For example, O2, N2, H2O. So first two are the molecules of elements. Third is the molecule of a compound. Next definition, atomic weight. I know how many of you are clear about this definition, but I have a feeling many children, what they do is till 9th standard, they just mug up this definition. Many of them, they are not able to understand. If you remember, you might have studied a number of times it is heavier than 1/12 of C12, something like that. Now, I'll make you understand before I dictate anything. Look here. Let us say I have three objects, A, B, and C. Their masses are 10 grams, 20 grams, and 100 grams. Listen very carefully. I can say this is 2 times heavier than this. I can say this is 10 times heavier than this. I can say this is 5 times heavier than this. Right? No problem. Very simple. Now tell me what will be 1/20th mass of B?
1.
1 gram.
Right? Earlier I said this is 5 times heavier than B. I can now say that this is 100 times heavier than 1/20th of the mass of an atom of B. I hope it's clear. It is 100 times heavier than 1/20th mass of B. Now I can also say this is 10 times heavier than 1/20th of the mass of B. Similarly, when we define atomic weight, standard chosen is C12. And the mass of C12 is 12 units. This unit is called AMU. We'll come to AMU later on, atomic mass unit. So the mass of one atom of C12 is 12 units. Now, 1/12 of the mass of an atom of C12. 1/12 of the mass of an atom of C12 will be 1 unit. Right? Now, we say that the atomic weight of magnesium is 24. Either I can say one atom of magnesium is 2 times heavier than one atom of C12, or I can also say it is 24 times heavier than 1/12 of the mass of an atom of C12.
Yeah.
So the definition which we have studied is in comparison with, we assign atomic weights or we assign molecular weights in comparison with the standard, and the standard chosen is C12. Every comparison is made on the basis of 1/12 of the mass of an atom of C12. Right? If I say atomic weight of oxygen is 16, now it is very simple. If I say oxygen atomic weight is 16, it means one atom of oxygen is 16 times heavier than 1/12 of the mass of an atom of C12. Because standard is this. And you should also know that long back standards have been changing. Sometime it was hydrogen as the standard. Oxygen was also a standard once upon a time. Now C12 is the standard because this is present in maximum number of compounds. This is present in maximum number of compounds. That is why the latest standard chosen is C12. Now write down. It is atomic weight. You can write AW. It is the number of times one atom of the element is heavier than 1/12 of the mass of an atom of C12 which is assigned a mass of.
Sir, could you repeat after one atom of an element?
I think you have some internet issue. Okay. Number of times one atom of the element is heavier than 1/12 of the mass of an atom of C12 which is assigned a mass of 12 units. For example, atomic weight of oxygen is 16, which means that one atom of oxygen is 16 times heavier than 1/12 of the mass of an atom of C12. Now, see, as I told you, in first few classes, you'll have the feeling you are as if you are in 8th or 9th standard or maximum up to 10th standard. But gradually, after maybe 3-4 classes, heat will be generated in the subject. See, if we talk about chlorine, atomic weight of chlorine is 35.5. I cannot say that one atom of chlorine is 35.5 times heavier than an atom of 1/12 of an atom of C12. No. Reason is there is no atom of chlorine which is 35.5 times heavier than 1/12 of the mass of C12. Then how come this 35.5 atomic weight for chlorine is being used? Chlorine has two isotopes which exist in nature. One is chlorine 35, the other is chlorine 37. Now, if these are two isotopes of chlorine which exist in nature, then should we take average of these two? Now, the problem is average of 35 and 37 is 36. It's not 35 even now. In fact, when we calculate average atomic weight of an element, then we take into consideration their percentage in nature. In nature, chlorine 35 isotope is 75% in nature, whereas 25% atoms of chlorine are chlorine 37 isotope. Then how do we calculate this 35.5 value, which is used in all calculations? Right on. Next paragraph. Atomic weight of most of the elements are fractional because atomic weight is the average of atomic weights of all isotopes of the element in the proportion in which they exist in nature. In the proportion in which they exist in nature. Underline this part. In the proportion in which they exist in nature. That is something very important. For example, two natural isotopes of chlorine are chlorine 35 and chlorine 37, which are 75% and 20% respectively in nature. Therefore, now you copy from the board. Average atomic weight of chlorine 35 into 75, 37 into 25 divided by total number of atoms. Total number of atoms are 75 plus 25, 100. So this is the meaning, in the proportion in which they exist in nature. So on this basis, I'm sharing one numerical. I think I don't have that. Okay, I'll dictate one numerical. You can try. Two isotopes. Okay, we'll do one thing. It will be difficult to dictate. We wind up the class. I'll share one numerical on your WhatsApp along with the answer, and see by using this method, you get the correct answer. Right? Chale. That's all for today. Next class on Saturday is 8 to 9 in the evening, not at 7:15. You might have seen my PDF as well. We'll start solving worksheets after a couple of classes. There will be assignments, worksheets as well, but they will start after 2 to 3 classes. Right, children?
Thank you.